Hello, this is Dr. Carroll. We're going to talk about dynamic data. Okay, dynamic data is the topic for today's discussion. To put that into context, we need to talk about a programming concept referred to as lifetimes. There's a couple lifetimes you need to know about. One is global. We talk about that. How long is a variable? What's its lifetime? If it's global, that means it's start to finish of execution. Okay, you could have a local lifetime, or you could. It's also known as automatic, and so the lifetime is equal to the scope. So if the variable's in scope, of course it's alive. It's like not alive, but you know what I mean. It's a lifetime. There's another local lifetime, and that's static. Okay, and that is also start to finish of execution. That's the keyword static is used for that. And then there's this last category, dynamic data, and its lifetime is from the call new to the call delete, or the end of the program. Okay, so now let's talk more about new. What is the syntax of new? So we could have new, and then we could have a data type. And so here's a single variable. Or we could have new data type, and then we could have an array. So then arrays take an int expression. And that is an array of what we're doing. Now, new does 2 to 3 things that new does. Okay, first, what it does is it allocates memory. Where does it allocate memory? On the heap. Okay, we'll talk more about that in just a second. The second thing that it does is it returns a pointer to that memory, which is again on the heap. The third thing it may or may not do is if data type is an object class, then it calls the default constructor. Okay, those are the 2 to 3 things that new does. So what is the heap? The heap is memory locations for dynamic data. How is that for a good circular definition? It's more importantly, it is different than the stack. It is also sometimes called the free store, and often it's positioned at the very end of the memory range. But so the heap, although there's even data structures called heap, but in terms of memory, the heap is where dynamic memory is allocated. Okay, well, let's see an example of these lifetimes. Here's, let's see, in the private chapter 1 directory, we have this file here. You can copy and paste it into Visual Studio, build it, and let's talk about it, okay? We have using namespace standard here. We've talked about that. So we have some global variables. We have a constant double pi, 3.1415. We have a global variable max number. So we have both a constant global and a variable global number. And now in main, we have some local variables, an integer, a static integer, and then we have an array. We have some dynamic memory here. We have int pointer, which is an integer pointer. I know, very clever name. And then we also have a heap array. So this is a single number, single variable here. We're just allocating memory location for 1 int. And here it's allocating memory for 7 ints. Then we print out what is the address of the variable and what is the variable, and it'll print it out. So what I want you to get from this is notice here what the, let's see, let's put it here. Notice the memory locations. The global variables are near each other in the memory space, pi, max number, and then the local variables in a very different place. But notice where our static variable is, it's right along with the global variable. What's its lifetime? It's from the beginning of the program until the end, okay? So in some ways, it's not a surprise that the memory location is similar to our globals, which have the same lifetime. Here, stack array is a local variable, and then int pointer, the pointer itself is on the stack. It is in that memory location, but what it points to is on the heap. Int pointer is on the stack, and a pointer, if you remember from the pointer video, stores an address of something. And what the address points to is on the heap. So same thing with the heap array. It's a memory location of the 7 ints that are stored on the heap. And you can see these are where the variables are stored in memory. I had to use the address of operator to get these. These already are memory locations, so I didn't need the address of operator there. If that didn't make sense, rewind and play it again and see if I make sense the second time. Okay. Let's see. Anything else I want to cover here? So if we wanted to assign something in the int to the memory location where int pointer is pointing to, we would do something like that. No, we need to dereference it so that it'll set it on the heap. Again, what this new does, remember, 3 things. It allocates memory on the heap. In this case, it's going to allocate memory for 7 integers, and it returns a pointer to the first byte of that memory location. And since int is a native data type, then it doesn't call the copy constructor there. So what's the difference here between a stack array and a heap array, besides that they have different sizes? The stack array, as the name suggests, is on the stack. All of its contents are on the stack. Okay? There's 2 differences with the heap array. One, heap array, technically speaking, is a pointer. The pointer is on the stack, but the address that it points to is on the heap. And so these 7 memory locations are on the heap. Okay? Now, how do we deallocate memory? Well, with delete. So delete deallocates memory. Okay, let's talk about syntax of delete. So the syntax is that you have delete pointer, if it's a single pointer, if new is called like that, or you might have delete the array notation and then the base pointer for it. Okay, so for every new, have a delete statement. For every new, have a delete statement. Okay, that's just a cardinal rule. Got it? For every new, have a delete statement. Okay, so if new is called in a loop, then you need to have a loop that calls delete. So now let's go fix our code, because for every new we have a delete. So now we need to add a delete int pointer, and then we also need a delete. The space is optional here, by the way. You can have it either way, and actually that space is optional as well. I like to put spaces in just so you can see what character it is. It's not a box or something. Then we would have heap array here as our pointer. We called new on, and we got a pointer. Now we need to call delete on it. We called new with array notation. We need to call delete with array notation. Okay. So what if we had a vehicle object. What if we had a pound include vehicle? And so we had a vehicle object. It's yelling at me because their one doesn't really exist, but we'll just pretend we can do that, okay? And so we wanted to have a vehicle object. How would we allocate memory for it? And let's say we wanted a pointer to it. Then we could have a car pointer 1, and we could say new vehicle. And what that's going to do is it's going to call the default constructor. Okay, there's another way we could do this. We could do it, we need a new variable name. We could do it with parentheses, and that also calls the default constructor. Now, vehicle is fictitious, so let's just assume that there is a non-default constructor. And let's pass it some arguments like a price. Let's say we got a, I don't know, maybe that's a good deal, depends on the vehicle. And let's say, oh, you know what, let's go with a 2015. That sounds like a good model year. And a model, let's go with an Express, okay? That sounds nice. So that calls the constructor, and as we mentioned, new does three things. It calls the constructor, or default constructor as the case may be. It allocates memory on heap for an object, your vehicle object, and returns a pointer to that. And those are the three things it does, okay? Now, if we wanted to get the price, if a price is one of the member methods of a vehicle, then we could have car pointer 1. It's a pointer, so we use the pointer notation, get price. And of course, it's going to yell at me for, oh, it just halved my screen. That was rude. I mean, you could have it in a C out statement or whatnot. Okay, so the pointers and objects, this is important. So what is the guideline for using the member of operator and the pointer operator? So if the left operand is a struct or a class, then use the member of operator. If the left operand is a pointer to a struct or a class, then use the pointer notation, okay? And we saw that here. We're using the pointer of notation here. Again, for every new, we have a delete. So now we need to add in some deletes here. Car pointer 1. Oh. Okay, keyboard shortcuts I'm getting. Okay, we need 2 and 3. So for every new, we have a delete. That is important. Okay, great.